5, we are going to be talking about quadrilaterals. Remind me what quadrilateral means. 4 sides. Okay? We are going to be talking mostly about one specific type of quadrilateral called a parallelogram. We're going to talk about a couple of other things, but most of the chapter is going to be concerned with this specific kind of a quadrilateral called a parallelogram. So first we're going to start by defining that. A parallelogram by definition is a quadrilateral, so 4 sides, with both pairs of opposite sides parallel. So kind of our standard drawing of a parallelogram looks like this. A square or rectangle is one specific kind of a parallelogram, and we will talk more about those later in the chapter as being special parallelograms, but our general parallelogram looks something like this. Today, along with that definition, both sets of opposite sides parallel, we're going to look at 3 properties of parallelograms. We're going to be proving these properties. We are not done with proofs, but Chapter 4 was our heaviest amount of proofs. So in Chapter 5, we will still have some proofs. On tonight's assignment, there will be 3 proofs, and then other problems. When we roll around to the Chapter 5 test, I think there's 2 proofs, and then lots of other problems. So we're not done with proofs. We won't be done with proofs until Christmas, but we're not going to have them in the massive amount that we did in Chapter 4 anymore. Okay, so that was kind of our peak. And then we'll still keep on doing them, just not as much.
Yeah, that's our best Christmas present.
Call me Santa. All right, so I'm going to label the sides of this A, B, C, D, and I'm going to draw on a diagonal. And I'm going to label some angles in here. 1, 2, 3, and 4. And that's going to help us out with this proof. So it says the opposite sides of a parallelogram are congruent. So we are basically given that we have a parallelogram. And the way that I'm going to write that is by saying that AB is parallel to DC. And that AD is parallel to BC, which I'll call our given. We are given the fact that we have a parallelogram, and parallelogram means that the opposite sides are parallel. So we're going to start by knowing that we have 2 sets of parallel sides because we have a parallelogram. Well, when we have parallel lines, we learned way back in Chapter 3 that they make some special angles. So what can we say about some angles in this picture?
1 and 4.
1 and 4 are congruent, and so are 2 and 3. If parallel, AIA congruent. I'm going to mark that up in my diagram then. 1 and 4, 2 and 3. This picture really looks a lot like stuff that we were just doing. So if this problem would have come in the last chapter, what is something else that we did a lot in these types of pictures? They're reflexive. So in this one we would say BD is congruent to DB by the reflexive property, which now gives us a picture of a parallelogram cut into 2 triangles, and those 2 triangles have 3 things marked as being equal. So from our last chapter, we learned that in triangles, if we can mark 3 things as being equal, then we can say our triangles are congruent. So triangle ABD is congruent to triangle CDB. Which one of our congruence methods would we use on this? Angle side angle. We know 2 angles and we know the connecting side.
Is that what we're supposed to prove?
That's not what we're supposed to prove. We're supposed to prove it says that opposite sides are congruent. But once we have congruent triangles, what can we do?
CPCTC.
CPCTC. Once we have congruent triangles, we can say that all their parts and pieces should match up. So then I can say that AB should be congruent to CD. And that AD should be congruent to CB. And that is CPCTC.
What does that stand for again?
Corresponding parts of congruent triangles are congruent.
Yes.
I'm confused. What are we trying to prove?
So you're trying to prove that the opposite sides of this parallelogram are congruent. So the top and the bottom are equal, and the left and the right are of equal length. So we now know two things about parallelograms. We know that the opposite sides are parallel, and we also know that the opposite sides are congruent. Our second theorem or property says that opposite angles of a parallelogram should be congruent. I'm going to use exactly the same picture as last time. And our proof would actually roll out pretty much the same way. Steps 1 to 4 are the same. Establish that we have congruent triangles. We're not going to go through writing all that again. First 4 steps, exactly the same. We want to establish that we have congruent triangles. But if we're trying to prove opposite angles are congruent, what would I want to say after I have congruent triangles then?
Angle A is congruent to angle C because of CPCTC.
Angle A is congruent to angle C by a CPCTC. So instead of saying something about sides, here we want to say something about angles. Now technically we've only shown that one set of opposite angles is congruent. To show the other set is congruent, what we would have to do is actually draw on the other diagonal AC and go through exactly the same process all over again. That seems like a little bit of a waste of time to me. So I'm going to say angle B is congruent to angle D by the same process.
Couldn't you just? Oh.
Could you say because of angle addition?
You could do some angle addition stuff also and say that because 2 is equal to 3 and 1 is equal to 4, and you could start to work that out a little bit as well. Using some angle addition.
So we'd have to do that all over again?
Yeah. Yeah, if we were truly going to show that, we would really have to draw on the other diagonal, show those two triangles are congruent, and then we could say CPCTC. So it would take like another 5 steps, and that's just not what we're doing. No.
What does that say next to 6?
Same process. We just draw the other diagonal and then do the exact same process. Our third and final property of a parallelogram today says that the diagonals bisect each other. So for this one, we're going to need a little bit different of a picture. I'm still going to label it A, B, C, D. I'm going to draw on one diagonal, but this time I'm actually going to draw on the other diagonal as well. And label my midpoint as M, that point in the middle of each of those then. And I'm going to label some angles in here. 1, 2, 3, and 4. So the theorem says diagonals of a parallelogram bisect each other. So the only thing that we know from the start is that this is a parallelogram, which should mean that AB is parallel to DC and AD is parallel to BC. Because what we have is a parallelogram, opposite sides should be parallel. Because we have parallels, what can we say? AIA are congruent. So what would be a pair of those?
1 and 3.
1 and 3.
4 and 2.
2 and 4. If parallel, AIA congruent. I'll mark those in our picture then. 1 and 3. 2 and 4. Once we have proven a property or theorem, we are then allowed to use that in other stuff. So what I'm going to do for step 3 is use a property that we already proved, which is that opposite sides are congruent. Specifically, I want to say that AB is congruent to CD. Our reason on that would be that property which says opposite sides of a parallelogram are congruent. I don't write the word parallelogram because it's long and I'm lazy, so I just draw a little parallelogram.
OSPC.
Okay. I don't know that I would know what that meant, so that might be too much of an abbreviation.
How do you tell the difference between that and a rhombus?
Yeah, that one actually kind of looks like a rhombus. A rhombus is a special parallelogram that we'll talk about later. So I'm going to mark those in the picture now. And when I mark those in the picture, I now have two triangles that have three markings in them. So I can say the triangle ABM, the top triangle, is congruent to triangle CDM, the bottom triangle. What type of congruence?
Angle side.
ASA.
ASA, angle side angle. I got two angles and I have the side that connects the angles.
So always gonna be angle side angle.
It will not.
Okay.
After we have two congruent triangles, then we can match up parts and pieces. We have to think about which parts and pieces do we want to match up. This property says the diagonals bisect each other. So what I want to talk about then are the diagonals. So I would want to say that AM is congruent to CM and that DM is congruent to BM. To bisect means to break into equal pieces. So then in our picture we can see that AM and CM should be the same, the two pieces of one diagonal. And BM and DM should be the same, two pieces of the other one. Now, common mistake here. All four of those pieces are not equal. There are two sets of equal pieces, but one of those diagonals is longer than the other one. So all four of those pieces are not the same. Okay? So each diagonal cuts the other one in half, but all those halves are not equal. Okay? Questions? Yes.
How does that work?
So, I mean, I could just draw like a picture and make it like really, that won't necessarily show it very well. Maybe if I make it, yeah, more like this. That diagonal is a lot longer than that one. So these two are equal, those two are equal, but all four are not equal.
Got it.
Okay. All right, so we know four things about parallelograms. We know by definition, opposite sides are parallel. We know our first property said opposite sides are congruent. Second property said opposite angles are congruent. And our third property said the diagonals bisect each other and cut each other in the middles. Okay? So those four pieces of information we're going to use in a few proofs on your assignment, but also to solve some problems. So I think I have a slide with these already drawn up. Yep. So we're going to look at these three problems. In these three problems, we want to solve for x, y, and z. These are all parallelograms. We are given that the figure is in fact a parallelogram, so we can apply any of these properties or definitions to the picture. It is not always necessarily easiest to solve for them alphabetically, so don't feel like you have to find x before you find y. You can just find whichever one makes the most sense to find first. So if x, y, and z, what is one of them I could know?
Y is 65.
Y is 65. Why is y 65?
Because of the opposite angles of the
Opposite angles of a parallelogram are congruent. That was one of our properties. So y is across from an angle that's labeled as 65, so those two angles should be the same. Alright, you can tell me another angle.
I think that x is 65
Why do you think x is 65?
because AD is parallel to BC and x is a corresponding angle of A.
Yeah, so we've got some corresponding angles. X is corresponding to the original 65. That's by the corner A. X is also alternate interior to Y. So either way of looking at that works, that we've got some angles that are either corresponding or alternate interior, and those parallel lines then should make those angles be the same. Yes?
Z is 115
How do you figure?
because 180 minus Z, 65 is Z.
Okay, so if this is 65, right next to a 65 needs to add up to a straight line, so that would have to be 115. And then opposite angles of a parallelogram are congruent, so Z would have to be 115. Sometimes in these problems, you will need to solve for an angle that you're not actually asked to solve for. So we weren't asked to solve for that angle that is labeled as 115 in the picture now. But by finding that, we were able to find something that we needed. Okay? So sometimes you have to find some other stuff. You can have found it without it, because in a parallelogram, we know opposite sides are parallel. And if I focus on just this side of the picture here, what kind of angles are those? Same side interior. And what do we know about same side interior? They add up to 180. So that would be another way of going about this problem without having to have found that other one. Two different routes to the same answer. Okay. Middle picture. Who can give me X, Y, or Z?
What's that number?
Kyler?
X is 56.
X is 56. Opposite angles of a parallelogram are congruent.
Where Z is 85.
Z is 85. Why?
Because the lines are parallel, so yeah.
We got some AIAs there. Z is AIA with the angle that is labeled as 85. Why?
Isn't Y 85 also?
Y is not necessarily 85.
95.
It is not 95.
85.
56.
It is not 56.
Oh, wait.
I know how to figure it out.
If I look at my sides being parallel and this line coming across, the angle labeled 56 and this whole corner are what kind of angles?
Same side interior.
Same side interior, which means they should add up to 180. So I can figure out what that whole upper right-hand corner is by doing 180 minus 56, and it's 124. And if part of that corner is already 85, the rest of the corner is 39. True. Questions on that?
Did we already do this before?
We have not. Similar types of problems, but not with parallelograms. That's an example. X is 110. Why? Vertical angles. X is 110, vertical angles.
Z is 70.
Z is 70. Why?
Parallel there.
AIA congruent.
Y is 40
How do you figure?
because 110 plus 70 is 180, and then 70 plus 70 would be 140, and 140 plus 40 is 180 for the triangle.
Okay, so right next to the 110, we can figure out that other inside angle is 70 because a straight line needs to make 180. Then I've got a little triangle that I outlined there, and back in chapter 3 we learned that inside of a triangle we should have 180 degrees. So far I've got a 70 and a 70, which covers 140, means there's 40 left over for the remaining angle.
It looks like it's 30 degrees shorter.
It may not be drawn to scale.
That looks like 60, 60, 60.
May not be drawn to scale. Alright, so important properties that you will be using in your homework problems are new properties from today. Look for AIAs or corresponding angles or same side interior angles because in a parallelogram we have parallel lines. Look for opposite angles being congruent. Look for diagonals bisecting each other. Look for triangles making 180 degrees. Okay. Your homework is from section 5.1. What is printed on your paper is right. This is wrong. This on your paper is an 8. And this on your paper is a 32. So your paper is correct. My slide is incorrect. You need your books for this chapter. Yep.